Dr. Chuck the Science Schmuck. Synchronize. Now, I don't know about you, but I know that quite often I find myself sitting in a basement breathing an atmosphere of 30% radon and contemplating my wood. Have you ever contemplated wood? Have you ever really thought about what wood is? Have you ever just gotten wood randomly, held it out in front of you, and thought about it? An interesting thing concerning this particular piece of firewood that you don't, well, you probably have thought about. If you're watching my channel, you're probably smart because you're watching me. And not liking and subscribing unless you really want to, because this channel is not currently monetized. But regardless, concerning the philosophy of wood, well, not really philosophy. Philosophy is for people with big brains. My brain is about the size of a chicken nugget and of similar consistency. And not one of the good chicken nuggets. It's one of the chicken nuggets made of beef. But wood is made primarily of cellulose, as well as like lignin and other things. Primarily carbohydrates, oddly enough. Cellulose is basically just glucose linked into starch, but done in a different way so that it's a lot more durable. It's a different connection pattern. But cellulose is therefore broken down into glucose, which is carbon, oxygen, and hydrogen. You burn that. We burn wood for fire. We need to make fire. Fire hot. Fire good. Fire also bad. Learned that last time with the smoke detectors. Possibly in the future, possibly in the past. Don't know where you line up on my timeline. Not in a time travel-y sense. I post videos really weird. Because I cannot focus. Because I do not drink enough coffee. The point being, when you burn wood, it releases carbon dioxide, water, and particulates, which are carbon, which are made of smoke. But what happens to the rest of the wood? What do you mean the rest of the wood? Well, that's because you haven't contemplated your wood long enough. You gotta just stare at it. Notice how wooden it is. Wood also contains trace amounts of nitrogen as well as sulfur in the form of protein. Yes, wood has protein. Not to the level you can eat it, but all living creatures, including trees, by definition have protein. It's what cells are made of. It's how cells perform basic operations. If you do not have protein, you are not alive. It's just how it works. Wood contains cells. This was once living. It was a branch or a very small trunk. I think it was a branch. When it is burned, nitrogen, which is a key component of amino acids, is released as nitrogen dioxide, which goes into the air and escapes, and it becomes nitric acid somewhere. Don't play with nitric acid. You'll either explode or get a bad burn, or end up drinking it somehow. Like, you know, that's why you can't buy it in stores. Little kids just kept drinking nitric acid. Sulfur is released as sulfur dioxide. That's only in... Oh boy, I always confuse the two. But I'm going to say cysteine. It's not cytosine. That's something else, or not real. It's a specific amino acid that has sulfur, and it's pretty common, and that releases sulfur dioxide when burned. But then you ask yourself, why does a man who does not own a cat have 40 pounds of kitty litter? The answer is, I'm not actually a man. I'm a machine. This is not full of kitty litter at all. Which, fun fact about kitty litter, it's actually made from dried, pulverized cats. Hence why it's called kitty litter. That is not a true fact. And if a fact is not true, can you even call it a fact? It's actually wood ash, made from burnt wood. I took it from my parents' wood stove. Because my parents have a wood stove, but I am too modern or too poor for a wood stove. I don't know. I burn oils. Now, you ask yourself, what is ash actually made of? I already told you that most of the reactions in wood, the carbon, hydrogen, oxygen becomes part of both of them. Disregarding the oxygen, which also escapes as a gas, nitrogen, sulfur, all escapes as gas. You burn wood, you have gas. I've got gas all the time coming out of my wood when I burn it. What's the ash made of? The short answer is metal. Wood ash is made of metal. And that sounds absurd, doesn't it? You think, oh, it's not metallic. It's actually metal oxide. Wood does contain trace amounts of metal. Specifically, in the case of ash, potassium. Sodium exists, but it's actually weirdly uncommon in terrestrial life. Like, if you want to try to find sodium in a living thing, it's tough. Like, it's really hard. Is that sodium over there? No, it's a wilting plant, and for some reason my garden is collapsing. Stop getting distracted. Stop drinking more coffee. I don't think it's actually helping as much as I think it's helping. The wood ash is largely made of potassium. Potassium oxide, because when potassium is burned, it doesn't produce a gas, it produces potassium oxide, which is a solid, which is what the white stuff in wood is primarily made out of. Also potassium carbonate to a lesser extent, which we're going to ignore for now because I don't want to make this more complicated than it already is. Also traces of iron, magnesium, calcium, manganese, it's all there. Wood ash is a pretty complicated substance. It also doesn't really have a flavor. Wood ash is, of course, generally safe to handle when dry. Which brings us to the point of this episode. I've been talking myself ragged. That's because I don't buy new clothes very often. But I've been talking myself ragged in circles to describe to you what happens when ash gets wet. Well, the answer is it becomes cake. If that cake is a lye. But don't shh. I made a funny. I feel good about myself today. Lye, or as some people call it, alkali hydroxide, which is what it is. They're not real voices, it's just my fish tank. It's a super weird sound. But when potassium hydroxide or sodium hydroxide, well, it starts off as oxide. You burn sodium, you burn potassium, but those are not very stable compounds. Recall from your basic 6th grade chemistry that anytime you have an alkali metal, potassium, sodium, all the rest of those guys, lithium too, but you're very rarely going to find lithium hydroxide, and that stuff just burns through anything. But regardless, when you combine such a thing with water, it dissociates. So you get oxygen and sodium, or in this case, oxygen and potassium. But you can't just have oxygen ions floating around in water. They steal a hydrogen atom and become hydroxide, which basically reconstitutes the whole structure of potassium oxide to potassium hydroxide. Beeping! Which is called lye. And that's the truth. Lye is traditionally a substance. It was used ancient times for making soap, which is a complicated process that I'm only talking about today in the scope of this experiment, making of the lye. So it's actually a pretty simple process. How do you make lye, you ask? Well, I'll tell you the truth. Yes, I just made the same joke like twice in like within a 2-minute span. So you take your pot. I use the same pot to make coffee as I make the corrosives, because in my case, the coffee's so strong there's not much of a difference. Stand up and make sure my wood doesn't get in the way. You never want to get your wood mixed with the corrosives. I know you can't see my head, but you can see my ash. Look at my ash. So, you want to take your ash and put your ash in the... Oh, don't breathe it. Wood ash is safe, generally speaking. It's not fun to breathe, because it is corrosive, to an extent. It's not very dangerous in its ashy form. I'm not going to collect that. So, ash in a bucket. Me with now newfound respiratory issues. Wow, it's echoey in here. I did remember my goggles this time, at least. So how do you convert this ash into lye? Well, I'm going to combine it with water, and then I am going to boil it. Boiling corrosives is always fun. Now, I usually do that shirtless, but for you I'll make an exception, and I will wear a shirt, because nobody wants to see that. And for one of the first times since the size video, I'm actually going to change locations, because I don't have an oven down here. You're going to see my upstairs. So, hold it, hold it. I'm going to move you right about, boop, now. Alright, you hear that? That's poor quality audio. Also, you can probably hear that fish tank in the distance. I'm actually just recording with the Schmuck Cam in portable mode for the first time ever. Now, as you can see, I'm in my Schmuck kitchen, my schmuck plants that you can't see because this camera can't pick up the amount of light I'd normally live in. I need constant darkness because light hurts my eyes and skin. It's part of the morlockification. As you can see, I've got my pot and my stirring knife. That is, in fact, my hand. That's the knife I use to stir my coffee, and I guess also corrosives now. Now, as you can see, I'm going to activate the fire. The fire looks much brighter for you than it does for me because the camera picks up the infrared light generated by the flames. They're normally a pale blue color. You see them as bright white. In the pot, well, not much to see in there. Hold on. I can do it for a second, but I'm going to hit another light. Oh, my eyes. Now, as you can see, the pot contains liquid. Tasty, tasty liquid. Very corrosive liquid. You will note that as soon as the wood ash becomes wet, it becomes potently corrosive and shouldn't be touched. For safety. I am wearing goggles behind this camera. You'll also notice this stuff is floating to the top. That stuff is charcoal, which is unburnt wood. It's sort of floaty. It will not really be an issue in the near future because I will simply filter the contents of the pot and then there won't really be a problem. You know, wouldn't it be weird if the audio quality... Oh, it's starting to go. But if the audio quality of this was actually better than it is on my expensive microphone, which costs like $30. Oh wow, that's going up quick. Yeah, if the quality on that's better, well, aren't I a dum-dum? I'm actually not a dum-dum. I'm a schmuck. Now, I'll let this boil for probably about 20 minutes to allow for as much of the potassium oxide as possible to dry. Dry? Whatever reaction this is, and then we will commence with the filtration. So, the lye has finished boiling. It's now very hot and corrosive. Now, a way to tell if lye is successful is to dip your finger in it when it's not super hot and determine if it is slippery. I'd recommend against that. It's corrosive and it'll burn your finger. Now, this is quite hot, but it should be lye. Now, as you can see, I have my lye bottle here. I used up all the old lye. That's why I'm making new lyes. It is important to keep your lye in either a metal or plastic container. Do not put it in glass. Most people don't fully realize it, but glass is in fact water soluble. It's not usually very quickly water soluble, but strong bases, which this is, it's not an acid, it's a base, bases corrode glass quickly, which is a property that you can actually use this for. We might get into that later. So, first let me scratch my face because I am itchy, probably from exposure to this corrosive steam. You probably can't see my head just because of the frame of view of the camera, but that doesn't matter too much. Nobody really needs to see my face. I'm not pretty. If I was pretty, this would be a lot easier. So as you can see, I got the top of a soda bottle filled with paper towels, which is going to be my lye filter. So I would stick my hand in there and swirl it around, but one, it's hot, and it will probably go right through the glove. Two, I use these gloves for repotting that cholla, and they have tiny holes in them, and I really don't want the lye getting in. So it's a sort of sloppy gray-brown color with a lot of particles of ash. Now, this may require some level of jump cutting, but as you can see, once the lye is poured in, it filters through, removing both traces of undissolved wood ash and the, why in the world do I sound like a recording? I haven't even been drinking any alcohol. Or have I? It removes all this particulate material, the wood ash and so forth, and the, unburnt charcoal. So, I'm going to jump cut forward until this is fully filtered, so that you don't have to sit here while I wait for liquids to flow through filters. I find it very amusing and satisfying, but you don't. Well, you might, but Oh boy, that took a long time to filter. It's not even entirely filtered. But, there you have it. A jar of lye. Well, actually a bottle. It used to have apple juice. Always be sure to label it. You don't want to confuse it for your apple juice because it will not taste the same. Now, you may notice that it is yellow in color. Why is it yellow? Well, I'm not 100% sure. If I had to wager a guess, I'd say it's probably trace amounts of transition metals like iron, but I really couldn't tell you. You will also notice that it sort of, as you pour it, if you're trying to do this at home for some reason, it is foamy, like soap kind of, with soap bubbles. Also, a lot more viscous than water. Kind of gooey. I mean, it's not jello exactly, but it's a lot more viscous than water. Now, you may be asking, why, you dirty schmuck, did you make a bunch of lye? The short answer is, because I can. The long answer is it has several important uses, mainly the fact that this is basically concentrated oven cleaner. It is probably one of the more powerful degreasers you can get. That won't really dissolve paint or anything, it just dissolves grease. That'll pull grease off of just about anything, including you if you get it on you. So it's a good cleaning solution. It's also good if you want to dissolve glass or silica. Now, as I mentioned before, contact with the substance does have a kind of greasy... Oh, it's hot. Yes, it has a very distinct greasy feeling, like you're touching soap, because it's actually turning you into soap to an extent, and it kind of burns. Gotta get to the science sink. Now, what happens if you do touch it? If you do get it on you, the first thing you want to do is rinse it off. Plenty of water. Remember, potassium hydroxide is water soluble. Diluting it is the first thing to do. It does have a hard time coming off. That's fine. If you really want to be 100% sure it's neutralized, apply vinegar. If you apply vinegar, it will automatically react. Vinegar is an acid. This is a very strong base. It will react into water and potassium acetate, which is a harmless derivative of vinegar. It's in the same way if you have an acid spill on yourself, put water on it, wash as much as you can off, dilute it, get it running off you as soon as possible. Do not hesitate. Do not let any corrosive sit on your skin. Wash it off. If it's on your clothes, as they told me in school, tear your clothes off, because pulling it up over your head, you're just going to spread it. Just Hulk out of it, just get in the shower, and just wash yourself if you have a bad spill. This stuff is not as bad as something like concentrated nitric acid. This is homemade stuff, but you still don't want to get it on you. I did that for the sake of demonstration, and it was only the very tips of my fingers, which are already heavily calloused. So I'll be fine, but do be careful when you go to do this. I will use this later, I think, to dissolve silica and recrystallize. You can do that by dissolving glass or sand or rocks or whatever you want for certain applications. I've done it before, but we'll cover it again later in a future episode. Thank you for watching. You don't need to bother hitting like or subscribe. You can if you really want to. You don't have to. This channel's not monetized because it's kind of boring to most people. And with that, extra.